All right, so last time we got up through 10.2, so we're in 10.3. So do me this favor. Let me talk about it, and then we'll try your problem out. So a good idea when you're doing something like getting into section 10.3, what 10.3 does is it takes inequalities, and normally inequalities you graph them on a number line, right? And that's what we call a single dimension, because you only have one choice to make in your motion. You go left or right. So now we're going to go to 2 dimensions, which means it can go up and down or left and right. So we're going to have 2 letters, x plus y greater than or equal to something. You guys kind of with me? So instead of x greater than 3, I might have x plus y greater than 3. So a good idea when you're changing, I'm going to say some phrase that you don't think you're going to hear every day, when you're stepping up in your dimensions. So we're going from 1 dimension to 2. You guys kind of with me? Going from x to x and y. Is to really analyze the hell out of what you did in a single dimension. And then try to extend that. So if I wanted to graph x less than or equal to 3, how would I graph that?
You put 3.
3 seems to be a very important point, right? Because what does 3 do?
It's included.
Good, 3 is included, but this is weird. This is very strange. 3, what 3 does is it cuts the number line into answers on this side, on one of the sides, and not answers on the other side. You with me? So we are over-analyzing the hell out of a single dimension, because we're about to step into freaking 2 dimensions, and I know it's going to make things weirder, right? But not if we do this. Not if you really think about what we're doing. So if I plot a 3 down, the reason we put that 3 down is the most important point. It's the dividing line between right and wrong. Good and evil. No, just correct answers and wrong answers, right? So of course I'm going to go in which direction? Yes, I'm going to put that little bracket and I'm going to go down. Because all these actually work. If I want to check it, I can pick a point like 1 and plug it in. Is 1 less than or equal to 3? Yes. It's less than, so it's less than or equal to. How he's doing so far? And you're like, yeah, I got that down, dude. Don't make that complicated. But I'm trying to make the next step easy. So when you take the next step, when I go from a number line to a plane, right? That's what the coordinate plane is. How do you cut it in half? I can't use a point to cut it in half. I have to use a line to cut it in half. I love it. You guys kind of with me? So if I have a single line, I just use a point to cut it in half. And of course, you put that little bracket on, but it's a point that I can cut that thing in half. If I have a plane or a piece of paper, how do I cut it in half? With a line through it, right? How we doing? You guys with me? Okay? So whatever the line is, it's going to do the same thing the point did. On one side, it's going to be shaded, because that's where the answers are. On the other side, it's not going to be shaded, because that's where the not answers are. Okay, so it's kind of cool to realize, I didn't have to think about that when we did this problem, because it was just so damn easy. But now that I'm going into 2 dimensions, I better think about what the hell this really means. So if I have a problem like y less than or equal to x plus 3. Can you graph the line that this describes? And what have I done that's really nice so that I can see the line?
You put in equal.
Yeah, I solved for y already. So of course the problems we have are not necessarily going to be solved for y. That's your first step. So how do I graph the line that this describes? What's the slope?
Is it like slope intercept?
Beautiful. What's the slope of the line? 1. And what's the y-intercept? 0.3. Sweet. All right. So you plot the y-intercept. And then you go
1.
Sure, up 1, over 1, or you can go down 1, back 1, whatever. And here's my line. Now on one side I'm going to shade, on the other side I'm not going to shade. Same exact idea as this. Let me stop right there. You guys get that? Because for example, let's try something I wouldn't normally try. Let's try the point 3, 2. That's on this side of it, right? So either everything works over here, or nothing does. So if I take one point and plug it in and it works, I'm going to shade where that point is. If it doesn't work, I'm going to shade on the other side. All I need is a single test point to see which way to go. So if I plug in 3, 2, how would that look? If I plugged in, this is my test point. How would that look?
3 plus 3 is 2.
Yeah, the 2, less than or equal to
6.
3 plus 3. 2 less than or equal to 6. Is that true?
Yes.
Yes. Cool. Which means that worked. Which means
All does not.
everything on this side works. Done. Which means if I pick a point over here, like the point negative 3, 4, if I plug that in, what should happen?
It wouldn't work.
Shouldn't work. So see, if I plug in 4 for y and negative 3 for x,
That's 0.
is 4 less than or equal to 0? Hell no. So there you go. So that did not work. It shouldn't work. How do we feel about this? We didn't have to do this kind of craziness here because it was only one dimension. I don't even have to really think about it, right? But now we're in freaking 2 dimensions. Everything's going to be a little bit more complicated, so we have to do it all the way out. We have to pick a point, and normally I'm not going to pick the point 3, 2. I'm going to pick the point 0, 0 if I can, because that'll make everything easy, right? So if I pick 0, 0, I get 0 less than 3. And that's true. I'm going to shade that way. Yes, ma'am?
Can you show me how you did this again? Like how you did the 2 something?
Here?
Yeah.
So I just picked any point I wanted to that's over here, 3, 2,
Okay.
and I plugged it in. So for example, up here, if I pick anything over here, so pick something over there. 5. 5 is over there. Does it work in this? Is 5 less than or equal to 3? That's why it's not shaded over there, right? So if you pick any point on either side of the line, if it works in here, that must be the side that works. That must be where all the answers are. If it doesn't work, that must be where all the not answers are, all the things that don't make it true. Let's do another one. Yeah. Beautiful. If the line goes through it, you can't use it. But then I would just use 1, 0 or something. Yeah.
So then you just shade the side where it does work?
Yeah, if it worked, I'll shade this side. If that didn't work, I would have just shaded the other side.
Is there going to be a time where they will?
Never.
Okay.
Yeah, it's got to be one side or the other. It's certainly, if I had, can you imagine anything you can write like this where I wouldn't shade either way? There's no way. I'd have to shade one way or the other. Yeah.
Is it only going to apply to when you have less than or equal to or greater than or equal to?
I'll show you the difference. What was the difference back when we were doing closed circle and open circle? If it was not equal to, I would have put an open circle. Right now, I put a parenthesis. So if this would have been not equal to, if it would have just been less than, I would have used a dotted line. That's kind of the equivalent of an open circle. I would have made a dotted line. That would mean that all the points in the line don't work. Because all the points in the line are where they equal this, right? Y equals this is the line. So I make the line not solid if it's not allowed to equal that line. Just try one problem like that. Sure. So of course the first thing I want to do is
Y by itself.
good, get y by itself. And how do you want to do this? A couple different ways you can do it. Minus 4x, okay. Good, negative y. And of course when you divide by negative 1,
You change the sign.
you have to flip that sign, good. And that never goes away, it's just always true. Whenever you divide and multiply by negative, you change the order of things. Is it cool? Okay, good. So what's the slope in the y-intercept?
4.
So the y-intercept is -2. Go
Up 4.
2, 3, 4 over 1, and I'm going to connect it with a what kind of line? Dotted line. All right. Because they're not allowed to equal. It's equivalent of parenthesis or open circle. So I'm saying the points on this line actually don't work. Points on this line don't matter. So we stop right there for a second. So that's equivalent to putting a bracket here or putting a parenthesis here. Right? So here my dividing thing is the point 3. So I shade one side, not the other side. Right? I put a symbol on that dividing point to say I use it or I don't use it. So this line, I would use those points because they work. They're allowed to equal that line. This one's not allowed to equal that line. I got to show that somehow visually. So dotted line is the quickest way to do it. If you rather make a bunch of little circles, that's nice. That's fine. I'm okay with that. Now, how do I figure out which way to shade? Yeah, so let's try 0, 0 since it's available. When would 0, 0 not be available? If the line goes through it, I can't use it. I have to use a point that's on one side or the other, not right on it. So this, thank God, this line does not go through 0, 0. So if I plug in 0, 0, 0 greater than 0 minus 2. Is 0 greater than -2? Yes. So I'm going to shade up. Let me show you another way to look at this. And you got to be real careful with what I'm about to say because lines get really steep and then up and down are weird. So let's see what I say. This is where the y's are bigger than the line values, right? So if I look at this value on the line, where's the y's bigger? Up. So when it's greater than, I shade up. When it's less than, I shade down. But it's a really steep line, it's weird what up and down are, right? So you got to be careful when it gets really steep. Okay, so let me let you guys try one. See if any other teachers come in here and threw some stuff. Let's go through his bag, see who's got any money. No. Yes, yeah. You can sell some, yeah. No, I don't want you guys to know this. That's my idea, anyway, guys. So here, you guys try this one. Which one, Jeff? I don't know. So first step here is to do what?
Well, subtract 2x.
Good. Get y by itself. So subtract 2x over
Divide by.
y by 3. So your y less than or equal to.
2/3 plus 3.
Cool. So now you see your y-intercept. So your slope. So y-intercept is 2 or 3. Down 2 over 1, 2, 3. What kind of line are you going to make?
Solid.
Solid?
C line, A line.
What the hell's that?
There's a
You
line.
see something, say something? Is that like
There's a
the...
line underneath the
Oh, okay. See a line, make a line. I
Yeah.
like it. Cool. You see that line, you make it. Make a line.
Shit on the bottom.
You still make a line if you don't see it, but you make a dotted line.
Right.
Right.
That's solid.
So now, how do you figure out which way to shape?
0, 0 point.
Test point. If you use 0, 0. So if you use 0, 0, this is going to look like 0 less than or equal to. And for some reason, I always get people that have this becomes 0, right?
Yes.
Okay. So 0 less than 3.
Yes.
Yes. So I'm going to shade it
Down.
that way. And my way would say shade down. Hey.
Yeah, so
I like it. That's fine. You can use it either way. I don't care. Is that cool?
I don't remember so much.
So I want to give you a little insight into the physical, real world reason for this kind of thing. It's kind of like a constraint. If I say the maximum weight of adults and kids on an elevator, it can be at most 40 or something. I can graph that constraint, right? And then I can say, hello. And I can say some other constraint, and I graph it, and I get this little region in here. That's my safe region. That's my region where people don't die. So this kind of thing is used a lot in when you have cases where you have electrical current, and it can't exceed a certain amount, and it can't go below a certain amount, and you can't have so much of this and so much of that. Then you see your safe operating area. So if you're over here, you're like, we should back down a bit because we're about to explode. Okay. Right? So it's good to know where your safe region is. You kind of follow what I'm trying to say here. So there's a physical purpose to this problem we're doing. There actually always is. But I just want to show you a good one for this one. Okay. This ain't too bad, right?
Just do it with the Z now.
Yes. We will actually. So. I'm going to blame it on you. Yeah.
With the slope, you know how it's negative 2 over 3? Is there ever a case where you don't go over?
Yeah, so the interesting about slope is that's negative 2 over 3. That means down 2 over 3, right? But negative 2/3 math would say that's the same thing as 2 over negative 3, which suddenly makes my slope different, doesn't it? Not different, really. I end up on the same line, but if I could go down 2 over 3, I should be able to go up 2 back 3 and still get back to the line again, right? That's exactly, this would mean over, up 2, back 3. So if I went up 2, back 3, I'm still on the line, right? So when you have a single negative, you could put it on the top or the bottom. Some of you guys actually have seen you do that, which is neat.
You're never going to do down 2 and then over negative.
Only if it's positive, believe it or not. If it was 2/3, isn't that the same thing as negative 2 over negative 3?
Yeah.
When the negatives cancel? But if I put them in there, isn't this down 2, back 3?
Yeah.
Cool. So the weird thing is it has to be totally positive in order for me to go down back. Because I can put negatives on top and bottom there. If you don't have a clue what I'm talking about, that's semi-bad, but not horrible. Should be able to just graph using the slope and the y-intercept. Okay. So one quick little special case. I'd have to be very specific with the instructions. I would say graph on a coordinate system, graph on an XY plane. So I'd have to say something that tells you it's 2 dimensions. So graph on an XY plane. So how would I graph this?
Y minus 2. You could get y equals minus 2, and you graph the line.
Yeah, but what kind of line is y equals -2?
It would be
Horizontal. So if y has to stay -2, it can't go up or down, because then y would change. So it must go left and right. And what kind of line is it going to be? Yeah, I don't see a line, so I don't make a line. Make it dotted. And then I want to shade down. So that's one I wouldn't even do a test point, really. It's just y less than that, so it's down all that stuff there. Cool. So that's a special case. When there's only an x or only a y, it's going to be a vertical line or a horizontal line.
That should be like a bonus question on that.
The easiest question should be bonus?
No,
No, keep wishing. So when you're missing a variable, it's only hard if you try to force it to work like other ones do. But when you're missing one of the variables, it's a special case. It's an easy case. It's either this guy if it's y, or it's this guy if it's x. So let that be easy. It's only when you try to force it to work like this guy does that's good. It's hard. It doesn't have both x and y. It's not going to be the same thing. Okay. So I'll tell you this. We still have 10 minutes. We are going to use them. Even though I actually do want to go home. It's too bad. I'm not going to let myself go home. We're going to get into 11.1. But I am going to make, now you're going to want to write this down. I'm going to make 11.2 extra credit. Oh, so I'm not going to cover it. But if you want to do it, you can do it. It's extra credit. So we're going to do 11.1 right now. It counts towards your homework score. So basically, if you ever do the homework extra credit and you do it, and you do all your homework, then your homework average is actually going to be over 100. But if you miss some or you don't do some corrections, then it's going to kind of take the place of some of that.
But you need some homework.
Huh?
You need some homework.
That's right. That's why I'm announcing it. I'm making a change. Yeah, so now it's extra credit.
So since it's like the 11 is extra credit, is it going to be a problem on the next test?
If it was, it would be in the bonus section.
You didn't put that 2 on the math lab, Jeff?
I didn't put any 11 up yet, did I? So I got to figure out how to do it. I'll make it its own separate thing so I can make it extra credit by itself.
Okay. So then like all the chapter 11 homework, so like the 11.
So then you've already got some extra credit. Kick ass. That's the best. I love when people start complaining. I'm like, you've already done it. It's done. And you got extra credit. I don't know what more you want. So you're good. So 11.1. Let's recall. Next. What's a really, really, really good way to solve this system of equations? Elimination. That's interesting. So how does that work?
Cancel the 2.
Yeah. So x is 1. Plug that back in, blah, blah, blah. Okay, so we all remember that, right? If that had not been a 2, I could just double this if it was a 1 to make these match up, right? Everybody remembers elimination. Because, like Carl said, and only because Carl said this, and also because we're going to do it anyway. Now I'm going to have equations like this. Actually, let's do this. For this first one, we're going to go into it knowing what the answer is. So you're going to help me make this problem. So an answer, I'm going to have 3 variables. We're not going to suddenly do a lot of 3-dimensional work. We're not going to have 3-dimensional geometry. But the idea is x, y, z would be x, y, z. So the z-axis is coming out of the board. You with me? So don't worry. Part of your homework, part of your test is not going to be stand up and go somewhere in the room and the point is here. No. It could be, but no. So geometrically what's going on is every time I write an equation like this, it's a plane. It's not just a line. That's a line. This is a plane now. So I could have a plane here and a plane there, like the ceiling. Everybody with me? And the plane there. Where is the answer to that system of equations with those 3 planes? Where do they all meet? The ceiling, this, and this. They all meet there. That point in the corner would be the answer. So my answer is going to be a point in three-dimensional space. It's just going to be like 1, 2, 3. Just like a point in two-dimensional space is 1, 2. Three-dimensional space, just add another number. Suddenly you're in 3 dimensions. I get the weirdest looks. So, let's come up with the answer first, which you don't get a chance to do very much. Somebody give me a number for x.
0.
I'll go with 1. Why? 4. Now give me a negative number. Negative 7. Look at that. 2 here at the same time. So what's got to be here? 1 plus 4 is 5. Minus 7 is negative 2. Now let's make another equation. So it could be something like 2x minus y plus 3z. You guys get the idea? So this is how I sometimes make problems so I know the answers aren't freaky. If I just made a problem up out of nowhere, I put money on it having answers like 11 over 217. I mean, it's going to have some ugly answers, right? So what would this have to be here? X is 1, so that would be 2. Minus 4 is negative 2. Minus 21 is negative 23.
So the x plus y or the first one?
This is x plus y. Yeah. Alright, and then one more equation. Let's say negative x plus 2y minus, what do you got, Jeff? 4z. So what would that be? That would be negative 1 plus 8. That's 7 so far. Plus 28. 35, right? Alright, so you guys semi with me? Are you ever going to have to do it yourself? No. But it is kind of nice to see how you can make a problem. Now in the real world, this would be 3 equations that come from the real world. They come from measuring the wind and measuring the density of wind in the air to figure out if you're going to have a freaky rainstorm like we did earlier. Right? But here we're just making it up. Now how do you think we're going to solve this? What's really wrong about this? What's really horrible trying to solve this? There's 3 freaking unknowns. So over here, what did we do? There were 2 unknowns and we killed one of them. And we immediately had an equation with 1 letter in it. Now if I kill like the x's, I'm still going to have shit. So the way to solve this by hand, is to kill a letter twice. If I kill x once, I get y's and z's. If I kill x again, I get another equation with y's and z's. And then those 2 I can do just like I did this. So I take 2 steps. I kill a letter first twice. And then I get 2 equations with 2 letters. I can kill one of those letters. So we just got to run through it. I can't describe it yet.
So then you just plug in what you get. And then keep going.
At the very end, it's like dominoes. You plug back in what the numbers you did.
Right.
So see how this works. So if I take, for example, which letter do you want to kill? Which one
The
looks...
first one, the y.
You have to pick one letter and kill it twice.
1.
So it doesn't matter. It'll kill x. X is not a bad choice because if I take 1 plus 3... Stop doing that, Jim. If I take 1 plus 3, what do I get?
You get
Let me write them down.
3y plus minus 3x.
Oh, what's minus 3?
So if I take 1, equation 1 plus equation 3, I like it. Something going, 4, right? Is it 4? Not today. It's not 4 today. Let's see. So now I get that.
3y minus 3z equals 33.
33, I like it. And what's really kind of nice about that, I can't take credit for this. It's available, everything's going to be divided by 3, right? So I get y minus z equals 11. That is my 4th equation, right? That's first, second, third's already taken. That is my 4th equation.
So now you have to get the second equation 1.
So this is a really good problem for developing your math stamina,
Your what?
right? Math stamina. Math requires stamina. People give up halfway through this problem because they're like, I've written so much already. That's too damn bad. Right? You got to get through it. This is not a hard problem. It's just a long problem. So if I add 1 and 3, I kill the x's. What's another way to kill the x's?
2 and
Now
1.
4 and 2. Never mind.
So 4 has no x's,
Never
right?
mind. I was wrong.
2 and 1.
What's another?
What's really nice about these two?
You can multiply
They're at least already
3
Yeah.
opposite signs, right?
by 2.
So if I take 2 plus,
3.
what's got to be here to kill these?
-1.
Twice 3. So if I take 2 plus twice 3, if I put a 2 there, isn't that going to kill? It's the same thing as what we did earlier with the 2 equations. If it's a 2 there, these would die.
See on the side of the 1, 2, 3.
Feel me? If I add these together right now, do the x's go away?
No.
No. What has to be here so the x's will die? A 2. So if I double this whole thing, it will cancel, right? So if I leave 2 alone, here's that one. Go. And I multiply the third one by 2, what do I get when I multiply the third one by 2?
I get 2x.
Cool. It's nothing different. It's the same thing we did with elimination before. Same thing. If it doesn't match up, we make it match up. We double that sucker so that they match up, right? So what do I get when I add those together? 3y minus 5z 47. And see how between these two, I know I'm out of time, but see how between these two, I could use substitution or elimination to kill a y or a z. So we'll finish this problem up next time.
And then as soon as you get 1,
Yeah, well, as soon as I get a number, I can plug it back in here. And then I got 2 numbers, I can plug it back in here. That's dominance. It falls backwards. Okay. I feel better.